All right, welcome to the next page. So we're just going to start with the bottom of the first page, and it just goes. And this is really Theorem 9. So when it's like referred to Theorem 9, like in the book, when I have like pictures taken, so this is Theorem 9 that's in the text. And it's if theta is the angle between A and B, so that 0 is less than or equal to theta is less than or equal to pi, then. And so here's another way that we could help determine the magnitude of the cross product. And that is by taking the magnitude of A times the magnitude of B and multiplying that by sine theta. Now, how to get here is basically based off of the same rule of, if I'm squaring the magnitude of a vector, it's just the dot product of that vector. And then there's a whole bunch of math that leads us to our theorem right here. And if you'd like to see that, let me know and I'll make a video of that. But I'm going to hold on. I'm not going to do that unless, somebody's out there wanting me to do that. And yet, by all means, I'll definitely show you the proof of this. But so we can find the magnitude of a cross product of two vectors without even really knowing what those, the actual, vector is. And so here's an example. So we want to find the magnitude of u cross v and determine whether u cross v is directed into the page or out of the page. So out of the page, if it's like coming up, out, like towards us as we're writing it down, or into the page if it's actually going into the book. So say, this is, flat, orange is coming towards me, and red is going down through your book, through the table. All right, so let's go ahead and find the cross product. And again, I'm trying to beat the time to get through all this. And so we're going to go ahead and use our theorem, and we're going to find the magnitude of the cross product of u and v, both those two vectors. And so we're going to set that equal to the magnitude of u times the magnitude of v sine 45 degrees. And then we're going to go ahead and multiply, we're going to substitute in our magnitude for u, which is 4, times our magnitude of v, which is 5. So I'm going to go ahead and do sine of 45. Sine of 45 is the square root of 2 over 2. And so we go ahead and multiply, and we're going to get 10 square root of 2. 20 over 2 is 10, and so we get 10 square root of 2. And so that's the magnitude of the cross product of u and v. And then what we're going to do is we're going to determine is this directed into the page or out of the page. Now, something that is very important is we want to see if it goes in or out. When we are doing the right-hand rule, it has to come from the same initial point. And so we check to see if this does come from the same initial point. And so we go back down. And both our vectors are coming from the same point. You see how they're both coming out of the same initial point. And so now we're going from u to v. And so what we do is we just basically put our right hand on vector u, where our palm is facing v. And if we're able to turn that to v without going over 180 degrees, then it's pointing outwards. And so, of course, here, if our hand is on u facing v, and we can go toward without going over 180, then our thumb is pointing up out of the page. So this is out of the page. All right, the next one. So here's another way to tell if two vectors are parallel. If we do the cross product of two vectors and it's equal to 0, then we know that the two non-zero vectors are going to be parallel. Another theorem that we have is that the length of the cross product of A and B, so the magnitude of A and B, is equal to the area of the parallelogram determined by A and B. So if I have two vectors A and B, and we've formed a parallelogram by their terminal points, what we can do is we can actually find the area of the parallelogram that is created. So here we have two vectors that are going out, and then where they stop, we're going to just go ahead and create a parallelogram. So parallel to, this is parallel to vector B, this is parallel to vector A, and then they form a parallelogram, and we can actually find the area of that by just taking the cross product. Alright, so here we want to find a non-zero vector orthogonal to the plane through points P, Q, and R, and find the area of the triangle PQR. And so the first thing that we're going to do is since these are actual points, we want to find some vectors. And so I'm going to find vector PQ first. And so all I'm going to do to find vector PQ is just take the difference of Q and P. So I'll do 0 minus -1, 5 minus 3, and 2 minus 1. And that's going to get me 1, 2, and 1 for the first one. So that's PQ. Now let's find PR. And I get 4 minus -1, 3 minus 3, and -1 minus 1. And I get 5, 0, -2. And now what I want to do is I want to find a non-zero vector that's orthogonal. To do that, I find the cross product of PQ and PR. So PQ cross PR. And this is going to find an orthogonal vector. And so this takes care of A. And so I'm going to go ahead and I'll just say I, J, K, 1, 2, 1, 5, 0, -2. And that's going to be, I'm going to go ahead and just show the multiplication. So for I, it's 2 times -2 minus 1 times 0. And that's I minus 1 times -2 minus 1 times 5 plus 1 times 0, and that's J. 1 times 0 minus 2 times 5 K. And so this will give me the orthogonal vector. 2 times -2 is -4 minus 0, so -4. I, 1 times -2 is -2 minus 5 is -7. Have a negative in front, so positive 7. So plus 7J. 1 times 0 is 0. 2 times 5 is 10 minus 10s. Okay. And so there is my orthogonal vector. And now what I want to do is find the area of the triangle. So to find the area of the triangle, alright, I'm going to go ahead and find the length or magnitude of PQ cross PR. And so take the square root of -4 squared plus 7 squared plus -10 squared. And so I get 16 square root of 16 plus 49 plus 100. And that's going to give me, let's see, 10, 59, 165, 165, square root of 165. Now, this is not the area of the triangle. This is the area of the parallelogram. And so if I want to find the area of a triangle, what I'm going to do is, because this is a parallelogram, all we need to do is divide this by 2. and that is the area of the parallelogram. All right, now the rest you here have is just theorems. Again, one that I want to highlight is this first one. Notice that A cross B is going to be equal to negative B cross A. Again, they're the same vector, they're just pointing in opposite directions. All right, and that was from the first thing that I was talking about. One's going up, the other one's going to go down, so that's why you have that negative. Again, that's going to be it for this page. Again,